the week. So yeah, last week we learned about what bonds are, and we learned about naming binary. When you're naming binary, that means you just take one from the left, one from the right, a metal, a nonmetal, and then they come together and you add an IDE ending, correct? Today, we are going to add what are called polyatomic ions. It's not super challenging. You guys can get it. If you can do last week, you can do this week. But the big thing that we're going to add are some parentheses, and we have to use them sparingly. Okay, tomorrow we're going to talk about formula weight. Formula weight is a little bit mathy, but not so mathy that I think you can't do it, and then a little bit of percentages, so you guys will be fine. We're going to practice everything on Wednesday. And then, unfortunately, I will not see you for the rest of the week. Okay, Thursday and Friday, we are remote so that the teachers can go get their vaccine, so we can all get back here sooner than later. So the lab that we have, we will try to make sure you guys get to do that at some point in time. And then the quiz will be as normal. You will just take it anytime between 7 and 1:30. Okay, so that's what we have as far as the week goes. So let's get into the packet. The first thing in the packet I want you to find is the worksheet, ionic compounds. It says 1.5 on it. I want to spend a minute refreshing what we did last week because I didn't get to see any of you physically last week to make sure you can do this. And those of you at home, thanks for coming. Let's make sure we all refresh. So to remind yourself about what we did last week, when you're writing an ionic formula, the first thing is the positive ion goes first. So your metal always goes first. Your positive ion goes first. And the biggest rule that you have to remember is that the total charge must be equal to 0 or neutral. The total charge must be equal to 0 or neutral. And if you need more than one thing, you need to write a subscript after the element you're talking about. And you guys all know that because if I asked you the formula of water, you could tell me H2O, and you would tell me that 2 talked about the hydrogen, correct? All right, so when you're writing a formula, and you've been given, for instance, magnesium and fluorine, everybody's going to get out their periodic table here. Hopefully everybody remembers. Where's your periodic table? Does everybody have the charges on their periodic table correct? Everybody has those numbers. Column is +1, second column is +2, +3, plus or minus 4, -3, -2, -1, 0. If you do not have those written because you didn't write them in the lecture last week, please make sure you do that now. +1, +2, +3. We're going to skip the D block. Then group 4 is plus or minus 4. Then we start going down the negative side. -3, -2, -1. And like we said, group 8 never will give or take electrons, so they are always neutral. Okay. All right. So when I look here, magnesium, I find him over here. He has a +2 charge. So what I'm going to write, +2 next to magnesium. And then fluorine over here has a -1 charge. Does +2 - 1 = 0? No. So if I'm writing this MgF, that would be wrong because that is not neutral. How many fluorines do I need to get to -2? I need 2 of them. So basically the numbers have to be equal. So if I have +2, I need 2 of the -1s to get neutral. Let's try another one. Sodium is in group 1. That's a +1. Oxygen is in group 6. That's a -2. Can anybody tell me what they might need? How many sodiums do I need? I need 2 sodiums. So it's going to be Na2O. Awesome. And then if you ever see something like this, aluminum is in group 3, so it's a +3. Sulfur is in group 6, so that's -2. What do 2 and 3 both go into? 6. How many aluminums do I need to get to +6? 2, yep, 2 of them total. And how many sulfurs do I need to get to -6? I need 3. Perfect. Okay, so now it's and 6, n minus 6, and everything is neutral. So that is very, very important when you're writing formulas. Questions on writing formulas. Awesome. Good stuff. Then you have to learn how to write the names like we did last week. Very easy rules again. Same thing. The positive ion goes first. The positive ion goes first. And you write out the full name or the entire name. Sodium, potassium, hydrogen, strontium. You write out the whole first name. And then for the second name, for the nonmetal or your negative ion, does anybody remember what you always add at the end? Yes, thank you. An IDE ending. So if I had a periodic table, and like I told you last week, I wrote big old IDE ending on my periodic table, and that means all of these guys over here always need an IDE ending. For instance, chloride, oxide, fluoride, sulfide, nitride, bromide, phosphide, carbide, iodide. Okay, so let's do a couple practices, and then we're going to be feeling good, ready for the new notes today. So again, first thing, everybody should have out their periodic table. What is the charge of a potassium? K. It's in group 1. Its charge is going to be, you got it, 1. Sulfur is in group 6, so its charge is going to be, yes. Now, if I were to draw 1 potassium and 1 sulfur, does that equal 0? I need 2 potassiums and 1 sulfur to make everything neutral. Plus 1, minus 2 equals 0. Good. Then you're going to write the formula, which is very simple. You just write what you have. Potassium, I have 2 of them. And sulfur, you don't need to write a 1. It's assumed. And then you just name it potassium. And then sulfur turns into sulfide. Sulfide. Okay. Awesome. Good stuff. Cool. All right. I'm going to start you on this one. Aluminum is a +3. Bromine is a -1. I want you to draw it out. I want you to tell me the formula. And I want you to tell me the name. I want to walk around, see where we're at. Those of you at home, hopefully this is easy for you. And then we're going to pick up today's stuff in just a second. All right, are we ready? So today we are going to learn to add one more thing. And those of you at home, I think you probably heard me talking about it. You do need this sheet. It's called the Polyatomic Ions sheet. And so what I want you guys to see is I just want you guys to watch something here really fast, okay? You guys know how to name this. This is calcium fluoride. That's easy. You know this next one, this is sodium nitride, right? Super simple. This one is barium chloride. You just cut the metal and the non-metal away from each other. There is another type of naming, though, in chemistry that's called polyatomic naming. So let me start over here on this one. You're like, wait a second, there are 3 of them. Where do we chop there? This is called potassium cyanide. This one's called calcium sulfate. Interesting. Then we have sodium bicarbonate. And you're like, oh, so you must just cut off the first one and then wait a second. This one's called ammonium hydroxide. Very interesting. So what you have to have is you have to have the sheet with information about these things called polyatomic ions. Let's get it to the bottom here, and let me tell you what the difference between these 2 things is. These first 3 right here are what are called binary naming. That's what you've already done. And the thing about binary naming is you have a metal and a non-metal that come together. Okay? You have a metal and a non-metal off the periodic table. So if they both come off the periodic table, you're doing binary naming, where you just name it and put an IDE ending on it. This new thing over here is what's called polyatomic. Does anybody know what the prefix poly means? Okay, many, lots. Okay, polyatomic probably means many what? Many atoms that work together as a single ion. Okay, so for instance, NH4 is a polyatomic ion. OH is a polyatomic ion. HCO3, they are many atoms that act like one thing. Okay, and they're off your polyatomic ion sheet. So here is an entire list of those items. All of those ions are right here. Perfect. Okay. Now, we're going to compare these two very quickly, and then we're going to be all right. When you are naming an ionic bond, like we just did, this is repetition, but that's okay. The positive ion goes first. So that means your metal goes first. And your anion has an IDE ending. So when you're doing binary, positive goes first. You have an IDE ending. Now to add in our new thing, your positive ion still goes first, your negative ion still goes second, but we have to pay attention to details. What you're going to see on your list are a few things. So here's your list. Where'd your list go? Awesome. Number one, people always forget about this guy over here. So I want you to draw a little arrow and say, look here. It's the only positive. Remember, cations are positive. This is the only positive polyatomic ion that we have. His name is ammonium. He's NH4. And the nice thing about this paper is it tells you the charge. So NH4 is going to be a +1. Over here, if you care, these are in alphabetical order. So if you're looking for a sulfate, don't start at the top. Okay. These are your anions. They're negative. They go second when you're writing them. And so on your notes, you will see it says what's the difference between a nitrate, a nitrite, and a nitride. Let's zoom down here. Do you guys see nitrate on here anywhere? I see nitrate right here. A nitrate is an NO3 with a -1. Where do we go here? A nitrate is an NO3 with a -1. What is a nitrite? Right underneath it, it's an NO2 with a -1. And then here, don't forget what we just did. What would a nitride be? If you see an IDE ending, you are going to want to look on your periodic table. Okay, nitride is nitrogen with a -3 charge. So they're not going away, those binaries. We're just adding more things together. Okay, so nitrate, nitrite, and nitride are all different. So you have to be careful when you're doing this. Okay, and remember, if you want to write yourself ID or right here, remember, binary is off the periodic table. Now, there are a few on here that have an IDE ending. For instance, like hydroxide. But you know there's no element called hydrox. So most IDEs are off the periodic table. So let's try a couple. These are easy. Let's do them together. What is the name of my metal here? It always goes first. We just write the full name. This is calcium. Can anybody look on there? When I see a multiple polyatomic ion, what is the name of CO3? On the top, go over, CO3. Carbonate. Very good. This is called calcium carbonate. Good. Then we'll go down. I said be very careful. People often forget to look at him. If it is a positive polyatomic ion, you guys want to make sure you look here. What is the name of NH4? Ammonium. Very nice. And OH, can anybody find the negative on the negative side? OH is hydroxide, ammonium hydroxide. I'm going to do one more with you. See if I can't get you caught up here. Tricky coming at you. Mg is what? Magnesium. And then you want to know what? I was looking for Br2 on my polyatomic ion sheet, but I just couldn't find it. If you see Br, that means it comes off of the periodic table. And what kind of ending does it need? It's magnesium IDE. Very good. Magnesium bromide. Okay, so you have to still do both. I want you to pick up with my Na2S, and I want you to finish this. I'm going to walk around. Anybody at home have any questions so far? Doing okay? Doing okay? All right, I'm going to sit down with you guys in just 1 second. We got to learn how to write formulas, and then I'm going to let everybody practice here. How's this going for you? Doing okay? Do you have that polyatomic ion sheet? Yeah, it's going to be hard without it. Here you go. You can have this one. Okay. Right? So if it's a sulfur, we're going to call it sulfide. And the list of them are back here. Okay. Yeah. So it's just an S, right? So it's just an S. We're going to look at the periodic table. What are the endings of all these? So sulfur is going to turn into sulfide. Very good. Go ahead, I see you. Yeah, I see them. Mm-hmm. Yeah. All right. So we just got to do the formula writing, and then we will just practice. Got about 15 minutes remaining. Everybody's good there. All right. Camera's still working. We're okay. We're going to make it. I would say finish up the one you're on. I hate to cut you short, but I'd rather get everybody going, and then everybody can have the rest of the period to practice on the back of the notes. Let's talk about formula writing. It's no different than what we did last week. We're just going to add one little thing. All right, so binary. What we were doing last week, same thing. You label the charge of each thing that's going to be involved in a compound. Label the charge and the charges of each of the ions, and then you have to make them neutral. So if you have a +3 and a -2, you need them both 6. If you have a +1 and a -2, you need to make them both 2. And you use a subscript if you need more than one. That is what we have been doing. Perfect. Now, the only thing we're going to do now is that we're adding our polyatomic ion sheet here is same thing. Label the charges of the ion. Same step. Again, the charge must be neutral. Nothing's different yet. The only thing that is different is if you need more than one, okay? For instance, let's say hydroxide is like this. If I want 2 hydroxides and I simply added 2 here, do you think that's getting me 2 hydroxides, or do you think that's just getting me 2 hydrogens? It's only getting me 2 hydrogens. So what you're going to have to start to do is use parentheses around what you want. So you write the polyatomic, like ammonium, NH4. How many of those do I want? Put it in parentheses and tell me how many you want of the whole thing, okay? So you use parentheses and then a subscript if you need more than one of these things only. Now, people are going to get so excited. They're going to be like, all right, magnesium bromide. Let's just put parentheses around. There's no reason to put parentheses here. If you wrote BR2, it's exactly the same thing. You only use it. So I, on mine, write really big. On my sheet, use parentheses if more than one of these things. Okay, so you can write it on there if you want. Use parentheses if more than one of these. Okay, all right. Let's get to some practice, shall we? Only need parentheses if you need more than one polyatomic ion. All right, so first step, write down your charges. Boron is off the periodic table. He's a +3. Cn. Can anybody find Cn for me on the polyatomic ion sheet? Polyatomic ion. Cyanide, very good, and it's a -1. So I'm going to do the exact same thing. If I have one boron and one cyanide, does that equal 0? No. How about 2 cyanides? Does that equal 0? No. 3 cyanides. +3 -3 is what I need for my total. Now let's write it. If I were to just write BCN with a 3 right here, is that getting me 3 cyanides? That's only giving me 3 nitrogens. So that's wrong. You put cyanide. What you have, put that in parentheses and say I want 3 of them. And then you just simply name it. B is boron. And Cn is cyanide. Boron, cyanide. Awesome. Very good. All right, let's try another one. NH4, again, sometimes I can't find him, but when I see it's a polyatomic and he's first, he's a +1. CO3. Anybody seeing CO3 for me around here on the polyatomic? That is a carbonate. Very nice. And the charge is a -2. Let's make this neutral. If I have 1 ammonium and 1 carbonate, is that neutral? No. How about if I have 2 ammoniums and 1 carbonate? Now I have +2, -2. This is where it gets tricky with your parentheses. I write that I have NH4. And how many of those bad boys do you need? You need 2. So let's put them in parentheses. NH4 is what my polyatomic ion is. Put parentheses around it. Boom. Then you give me a 2. How many carbonates do I need? If you need 1 of them, it doesn't need parentheses. Be sparing with your parentheses. They start to get all cluttered. And then we're just going to write the name. Ammonium carbonate. Okay? I'm going to do one more, and then I'm going to turn you guys to just do your own, okay? Because this one is a binary one, so we're going to shift gears back to what we were doing last week. Sodium on my periodic table is a +1. You know, I looked all over my polyatomic ion sheet and I couldn't find an O by itself. If it's just a single element, you're still on this periodic table, guys, okay? And that's a -2 because that's just oxygen. So sodium is a +1. Oxygen is a -2. Is that neutral? No, it's not. So I need 2 sodiums. So what would be my formula? Na. How many do I have? 2. Now notice how I did not put parentheses there because you don't use parentheses off the periodic table. The only time you use parentheses is off your polyatomic ion sheet. And how many oxygens do we have? Simply one. Very good. Very good. Now, when we're naming this, sodium, what do you think the name of the second thing is? Oxide. Very good. Because now we're back off the periodic table. And when it's off the periodic table, it has an IDE ending. Are you with me? So they're going to have both polyatomic and binary on your quiz on Friday. So what I want you to do is I want you to finish this. And then at the bottom, it's just a little bit more formula writing. So sodium is a +1, bicarbonate is a -1. Let's see you guys do this. And then we also have 3 lecture questions. So I would have you get out your laptops, get into your lecture questions. Those of you at home, same thing, get those lecture questions going. Let's see how we can do.